All right, good evening, and welcome to Kopernik Observatory. I want to welcome the friendly crowd here at Kopernik, and also want to welcome those watching on our live stream. It's another cloudy Friday night, which seems to be, we've got quite a streak going there, but, and it's unfortunate that this weekend in particular, it's cloudy because if you're anywhere above the Mason-Dixon line, it seems that you have an opportunity to see possibly some northern lights. So if you're if you're watching online and you happen to be not in the southern tier, if you want to look out sometime this evening. Also, tomorrow evening is even supposed to be even better, I believe. And but anyway, it's great to have you here with us this evening. Friday nights are really an opportunity for us to expand our knowledge of the world and the universe. And as I like to say, we are more than just three telescopes on the top of a hill. But today we actually are, in fact, going to loop back and get back into astronomy, which is really our wheelhouse. This evening we've got one of our educators, Olaf Seegers. He's going to talk about some of his favorite planets that are out there and what makes them unique. And you'll soon find out there's more to rings than just Saturn. So at this point, I'm going to just turn it right over to Robert and let you take it from here. So let me get this.
Okay.
Are you turned on all the way on? All the way. Give it a second and try it out.
Check. Yep. That's good.
Okay.
I want to dim it a little bit here.
What?
I want to make the light a little bit.
Oh, yeah.
Awesome, thank you. All right, well, howdy everybody. So actually I got this idea for this. Last year my daughter actually, for her science fair at her school, came up with this, like as far as other planets besides Saturn that had rings. She was kind of intrigued by that. And so we kind of just did a little research for that, and then we kind of thought, hey, this is pretty neat. Maybe it deserves a little bit more attention because I really feel most people don't know other than Saturn's rings, maybe Uranus's rings as well, but other than that, nobody really mentions any other ones here. So, all right. So this is a historical approach. Not a hysterical approach like Drew noticed my typo, so it's a historical approach. Okay. And actually our very first, I guess the beginning of all this started with Galileo, who of course is noted for all of his great discoveries, including Jupiter's giant moons and so forth. But when he drew his sketches of Saturn, you can see something is very different here. So he thought they might be attached to Saturn. He wasn't exactly sure what they were, but he certainly was on the right track. So he kind of got this all started. So, and then this guy Christopher Wren, he was from London, and he actually hypothesized there was a ring around Saturn, but he didn't know whether they were attached or independent. He was kind of working on like presenting this. But before I switch to the next screen here, I should mention this guy is actually more famous for being an architect. He actually, apparently there was this huge fire in London in 1666, and he actually redesigned the city, including the famous St. Paul's Cathedral. So he was a major mathematician, scientist, and architect here. But he actually favored this other guy's ideas about the ring more, and that was Christian Huygens, who actually the Huygens probe from the Cassini spacecraft actually was named after Huygens, and the Huygens also, he discovered Titan, that was Saturn's giant moon, so the Huygens probe actually landed on Saturn. So I like how they kind of give credit to the people who did all this work so long ago. So he figured out that there was basically a ring system around Saturn and it was detached. And you can see his drawings. And keep in mind, too, the telescopes are improving at this time, too. So what he looked through was more advanced than what Galileo looked through. So, yeah, and here's this publication that he hit here. So the next big name here is Cassini, Giovanni Cassini, who noticed a gap in Saturn's rings, and we'll see what that is momentarily. But it's called the Cassini division, again named after one of the old timers here. He also discovered 4 of Saturn's giant moons. And a couple other guys along the way here. Laplace believed that he thought, that the Saturn's ring was comprised of solid ringlets, but James Clerk Maxwell realized they would not be stable and he thought they were actually made of the individual particles, which they actually are made of. So again, a lot of people kind of built this up. And here is the last old timer we'll mention, J.E. Keeler, and he not only realized that they were made of small particles, but he realized they didn't rotate as a solid body. And he discovered the Encke gap, which is in there too, which we'll see here in a moment. So here we go to Saturn. So the first spacecraft to visit Saturn was the Pioneer 11 back in 1979. Here's a picture of Saturn from it. Of course, there weren't any friendly Saturnalians to include the photo of the spacecraft. I think that was dubbed in, of course. And here is now the most recent ones from the Cassini spacecraft. And just amazing. The Cassini mission lasted so long. It was just, we learned so much from it. Here we can see, if you can see that Cassini division is that, this has got a pointer on it, doesn't it? So you can see here, there's between the A ring and the B ring, and then there's a C ring down here. So those are the 3 main ones, and there's some other smaller rings that we'll see here. But those gaps are called divisions, and that is the Cassini one, the big one right there. All right, see here. And the rings are made up of ice and rock and dirt and dust. Saturn itself is one of the gas giant planets. It does have a solid core way down inside, but it's basically a big ball of hydrogen and helium. So here we see a close-up of the rings. And of course, they look like they're planks, but it's just really a blizzard of material, like zipping around Saturn at, around 40,000 miles per hour. So it's so fast, you just see this blur, And you see these waves, and it's pretty interesting what causes these waves in the rings. So that was kind of intriguing. And it turns out, and you can see here, this one's like being braided almost. Okay, you can see this little guy here is what they call a shepherd moon. There's these smaller moons within Saturn's rings here, and some outside, and they basically, their microgravity, whatever, actually helps shape these rings, and they're involved with keeping the rings intact. And you can see we'll take a look at Saturn's rings here, and you can see some of these moons here, and these 2 here, they help keep the A-ring stable, Janus and Epimetheus. I'll get to them in a second. And then there's in the Encke division here, Encke gap it's really called, there's Pan and Atlas and so forth. But there's just a whole bunch of these guys, and they're relatively small, but a couple of them are bigger, so we'll take a look at it. And you can see, oh, by the way, before I move this here, you can see this like kind of very diffuse. Oh man, I didn't mean to hit that button. Here we go. That is what the where the E-ring is, and they believe that comes from all the geysers from Enceladus. Enceladus is this really special moon of Saturn's that has water on it just below the surface, and there's geysers that shoot off the water, and it's shot out into space. A lot of it is, and it sort of forms the E-ring that we're looking at here. And then Enceladus actually is, right now, astronomers pretty much feel it's the best chance of life somewhere else in our solar system other than Earth. So Okay, here we go. And it's really interesting too. These shepherd moons rather, they work together, and they have these interesting resonances. And I'll get to that here.
It looks a bit like a boat.
What's that?
It looks like a boat.
It does actually, yeah. Wait, yeah. Well, that looks kind of like a walnut or something. But here we go. So the two ones, they're probably the biggest ones. Janus is the biggest one. It's just about 100 miles across. And with its partner Epimetheus, the two of them are in a 7-6 resonance. So what that means is that for every 7 times Epimetheus goes around, Janus goes around 6. Janus is just a little bit bigger. And so they basically work, work like that. So it's really interesting how they do that. A close-up of Epimetheus.
Are they captured asteroids?
It could be. It could also be like if there's collisions. There's the ring. Obviously, those rings are caused by collisions, or so. Yeah.
But this is supposed to be these small satellites. They're rocky structures, to the best of my knowledge.
The smaller ones are, they're definitely rockier. So, whereas a lot of the other moons of Saturn are there's like a lot of ice, So, but we can check into that later for sure. So, before I do that, let me go back here. I have something else for you. Okay, so let me do this here. Let's get rid of this here. All right. Was that that bottom one, Drew? To switch to that? Yeah, to get to the YouTube thing.
Alt tab.
Oh, Alt tab. Sorry. Thanks. Yeah.
Hold on Alt.
Alt here and then
Hit tab. And then look.
Gotcha.
No, you want to get to YouTube. That's which is
It's
right
right.
here.
Oh,
Okay,
yeah.
so then click up there.
Okay. Thanks.
And then,
All right. So, just a little something as we leave Saturn. sorry. I was hoping we'd get through that movie without an advertisement. So the next stop for rings being discovered is our seventh planet, Uranus. And I guess the credit is being given to the Kyborn Airborne Observatory in 1977 for observing the rings for the first time. But you should know that the planet's discoverer, William Herschel, who discovered it in 1786, made notes. He thought he saw rings around the planet, and he actually had some like drawings and so forth. But they never have given him credit for it because nobody else saw it between like the 1790s and 1977, which is a pretty long haul. So we'll see. But he made a case for him back in like I said, the 1790s. So that's pretty interesting. So there was when they first discovered here in the modern era, they saw 9 rings, but then the Voyager spacecraft found 2 more, and then recently the James Webb telescope picked out 2 more. So there's actually a total of 13 altogether. So here's a image of the Voyager spacecraft that Voyager 2. Voyager 1 did not go there. Voyager 2 went on to Uranus and Neptune. And here's one of the Voyager images of Uranus's rings. And Uranus's rings are more dirt, dust. They don't have. It's not as icy, and therefore not as reflective. So they're harder to see than the rings around Saturn. Okay, so here we gives you an idea of where the rings are located on the planet here. And the thing too interesting about the rings of this planet are they're up and down. So Uranus is tipped on its side, so the poles are here, and so the rings do like basically go around the equator of the planet. But it's just kind of funny. It looks like it's rolling on its side as it goes around the sun. And just some more of the same thing. There's some the rings are named after I guess Greek alphabet names here. It just shows you where they are. A lot of smaller moons in the Uranus system, and there's actually a couple of shepherd moons too. I want to say, yeah, there is a pair. Cordelia is one of them. I forget the other one's name, but so there is not as much as Saturn, but there is a little bit going on there with shepherd moons as well. It kind of gives you the location of where these rings are if you look, from the poles. So.
Does Uranus actually have a bulge like that? Or is that an exaggeration?
I think it might be an exaggeration, but it's called oblateness when the planets, because of the way they spin, they all are they kind of pancake a little bit. So we'll see a great example of that really soon here. But it does have a little bit of a bulge. I'm not sure if if that was my fitting this image onto the screen or what. But and here is a James Webb telescope picture of this. So just last year, pretty cool. Yeah. Actually, even though Jupiter's closer to us, its rings were not discovered until a couple years later, 1979, when the Voyager 1 and 2 spacecraft arrived there. They're very, very thin, Jupiter's moons. By the way, I forgot to mention with Saturn's moons, they're like, I want to say they're like 140,000 kilometers wide, okay? And they're only about 32 feet, thick. So they're really, so when Saturn is actually facing us straight on during its equinox, if you want to call it that, we can't see them. We don't see Saturn's rings. It has to be tipped for us to see them. So.
It's like looking at the side of a sheet of paper.
Yeah, exactly. That's a great way of putting it. So. All right. So So here you can see there's just like the 4 dust rings, they call them, again because they're dust. That's why they're not very, very bright. Some of these ones, like I know Amalthea is like it's the 5th largest moon around Jupiter, but it's small. It's like barely over 100 miles across. But it too leaves like a trail, kind of like Enceladus does. But in this case, it's like dust. And so moving on to Neptune, and Neptune also didn't see any rings there until 1989 when the Voyager 2 got there. So, and I should say my last presentation was Neptune. so these rings, let's see if we can get the next page here. Oh, here, let's take a look at a James Webb picture here. It's also just a very recent photo. You can see them with some of the smaller moons, and then the giant moon, Triton. Oh man, they did it again. The giant moon, Triton, right here, which is one of the 7 giant moons of the solar system, just a tiny bit smaller than our own moon, but also has geysers of like nitrogen and water and so forth. That's why that one's so bright. But anyway, so we can see Uranus through James Webb. And so the 5 rings of Neptune are all named after the people that were involved with its discovery. And for those of you that don't know this, there was like big controversy. The people found it at the same time. It was like a race to find it. And then there was like lawsuits, who was getting credit for it. This is all back in 1848 and the years after. But now all these people are living harmoniously, orbiting Neptune like in peace, right? So they're all together again, so to speak. And here are the names of the planets. Basically, it was Adams and Leverrier who actually knew where it was going to be. But Leverrier actually got this guy, Gall, at the Berlin Observatory to actually find it the very night that he gave him the information. He actually found it. And these other people were involved with it too. But anyway, just kind of a fun story. So. There's a book out there called The Neptune Files, which is all about that, which is a great read. I know there's a couple other people here that have read it. So, all right. So here we can see some of the moons here, like near the rings. And let's see here. Again, very dusty rings. Very dark. They're not very bright. So moving on, we have some dwarf planets, and there's a dwarf planet called Haumea, and this is a Hubble image of Haumea. And what you see here is the planet. And by the way, Haumea is about this, just a little bit smaller than Pluto, very, very close. So let me get here. Here we go. There's Haumea, and those are its 2 moons. And of course, because the image is like flooded with light, that's why they're kind of blurred and so forth. Otherwise, it'd be like these 2 tiny points, and we'll see how they find these things here in a moment with one of the other dwarf planets. So, yep. So I'm not going to even try to pronounce the moon's names, but the rings were discovered in 2017. So.
Excuse me. So what's the Haumea's rings made of?
With the Haumea, they're more with ice. So the ones that we're going to see now, the dwarf planet moons rings rather, are made primarily of ice. The question was, what were Haumea's rings made of? And it's more ice as opposed to the dirt and dust we just saw with Uranus and Neptune and Jupiter. Okay. And here it's intriguing to see where these orbits are. So here we see Haumea, and it's kind of, you can see here, you see it kind of goes within Pluto's orbit, then other times it's out. It's a little bit more on the same plane, whereas Pluto's tipped like 17 degrees. Not quite as far out as Makemake. This here is the Kuiper belt. Those are those icy objects beyond Neptune. Eris is another large dwarf planet. So to answer the question about them like kind of bulging, this is a classic one. This is, like I say, it's about the same size as Pluto, but it spins so fast. It only takes 4 hours to make one rotation on its axis. So that's why pancakes to the poles here would be like, looks like an egg here, and here. And the equator is here, and notice where the ring is. Now this is an artist's rendering. Like I say, these are tiny specks that they like decipher, they analyze, and then they have artists like go ahead and make diagrams based on scientific information. So, but anyway, so here we see this one?
Just a question, why would it have so fast a spin angular momentum?
That's a good question, actually. I'm not sure.
This thing is in orbit about, or not?
It orbits, it takes around roughly the same, I think it's like in a 7-4 resonance with Neptune, so that's maybe a little bit longer than Pluto to go around. But these, it's hard to say, maybe when it went by another body and it accelerated. I don't know. That's a great question. We can look it up afterwards. So, I always like learning more about this. So, and here again, here's an artist rendition of it. This is the fun part, because you'll bore people if you just have these little dots, like I said. So they have artists really again using the information they have. So it's not all fantasy. I mean, it's based on some facts. So here is Quaoar. Quaoar is actually very important. It was the first major-sized dwarf planet found after Pluto. Keep in mind, Pluto was discovered in 1930. So they found these other really small ones, but Quaoar was one that's it's close. It's like just almost 2/3 the size of Pluto. So it's pretty decent. And what you're looking at here in this picture is how they basically find them. They look on successive nights where they are located. So you can see. Here's Quaoar right here. And all this here is wallpaper. These are stars. Stars and other, deep space objects. They never appear to move in our lifetime. They're trillions upon trillions of miles away. So even though Quaoar is a couple billion miles away, which sounds really far, that's in our solar system. We can see that move up against the stellar background. So.
Are those fuzzy blotches galaxies?
I think so, yeah. So there's so many of those out there too. So, yeah. It'd be interesting to see. We could probably figure out what constellation they found Quaoar in, and we might be able to find, which galaxies those are. And you can see Quaoar's orbit. It's a little farther out than Pluto, as you can see. But at times it's within Pluto's orbit. So Quaoar has a moon called Weiwat, and again, this is an artist thing. But we see here this ring. I'm going to just see if anybody can see what kind of detectors we have here. What's kind of unusual about maybe this ring compared to some of the other ones you just looked at?
It's really far out.
Yeah, I guess he said it's really far out, and he's exactly right. And that's a big puzzle. They call it, well, let me get to the screen here. There's something called the Roche limit. And what that means is that anything within that, anything within that basically gets within the Roche limit, it becomes a ring, okay? And particles, what they do is they start going around the planet. Beyond the Roche limit, they get crushed. So, and they coalesce into like a moon. So in theory, what would happen if it was this far from Quart, this should be a moon. So maybe one of the mysteries is, one of the ideas is maybe this is a moon about to be made, possibly, right? Another theory is that maybe it's just so cold out there, the objects don't stick as well as they do. So maybe like glue, like here, go to another cold day. So yeah, so what they're saying is that maybe it's just too cold for the parts to stick, as they collide. So that's what's a mystery. And I want to see if I remember how far away they are. Yeah, the outer one is about 3,200 miles away from the planet, and the smaller one is within the limit, and that is about 1,700 miles. So, nice guess, by the way. That was good. And here we can see another diagram of that. You can see how far away. That could be. That's where maybe the sun. That's a good question. Actually, I'll have to look that up. But it could be maybe sunlight was coming through that. Maybe they kind of put the ring image on there. Obviously, that's an artist version of that. So maybe they're just trying to create where the sun would be going through it. So that's a good question. And besides the dwarf planets, there's a couple of, I guess you'd call them asteroids, but you can also call them comets. They're kind of like both. They call them centaurs. It's a group of objects that basically run between Saturn and Uranus, but they kind of stretch out a little bit towards Neptune and towards Jupiter. And they kind of have a little bit more in common with comets. Here's a telescopic image from Hubble here. And that has, you can almost see it has a coma to it, like a comet would right here. So, and you can see kind of where its orbit is over here. Like I said, it's one of the bigger ones. And this was, I think, like around just before even the beginning of this century, they found this. The rings here. And then a larger one, in fact, this is the largest of the centaurs, Chariklo, and it's about 188 miles across. And in 2013, a group of astronomers from different observatories in South America worked together to actually find these rings. Again, they're made with water, ice, whatever. So they're icier than the dusty and dirty ones. Okay, you can see Chirico's orbit here. And just a diagram showing you how the rings would be basically from the planet. Once again, you can see just how very far the Quorus outer ring. It's actually called QR2, and the other ring is called QR1. And that's pretty much about it, although we have found a ring around a star, Fomalhaut, which is actually one of the brighter stars here. It's about 25 light years away, so it's not all that far. It's in a constellation called Pisces Austrinius. It means like the southern fish. And we see it here mainly in the fall. Like it's in the southern horizon in the nights in the fall. And what they found was like about 3 or 4 planets, and they think that these planets somehow, just the way they interact with each other, they kind of created like an asteroid belt, and that's where these rings pretty much formed from that. So, and this was, of course, that was by Hubble. I think also James Webb is also looking at it as well. So, but again, it's sort of an artist's tradition. But well, any questions at all? I mean, it was kind of quick here, but Any thoughts?
Do you think a moon could have a ring around it?
Could a moon, and so the question is, can a moon have a ring around it? And they're actually, for a while, they thought Saturn's moon Rhea had a ring around it, but I think they could not prove that again. So I guess it depends on where it is, like where how far it is from other larger objects and stuff. So that could be. So I guess it's location, right? So.
I know this isn't the same thing, but many moons ago, when I was young, I was down visiting my grandmother down in Florida, and it was about 1, 2 in the morning. I was down at the beach, just sitting there listening to the waves. There was a full moon, and there was a complete rainbow encircled the moon. It was an awesome sight.
Yeah.
That's an optical phenomenon from our atmosphere today.
Yeah, I know.
Yeah.
But it looked like a ring around the moon.
Yeah. Wouldn't that be cool to see that every day, right? If you can see a ring around it. Yeah. Question?
Where is Saturn's Roche limit relative to the rings?
Yeah, that's a really good question. I don't know the answer to that. Where is Saturn's Roche limit compared to its rings? So the farthest out moon of Saturn is Phoebe. So, yeah, so I'm trying to think how far. That's like can go as far as a couple million miles away from Saturn. So maybe that's the limit. We could actually look at that here afterward too. That's a great question actually. So, but it seems like the rings actually stop. Well, they go just past Enceladus, and then we can go back to that one. Let's see if we can go back to that one slide here. There was a good image of that. So. Okay. So the last of the rings is by Enceladus, is where Enceladus is. Now that again, that they do believe Enceladus is where that ring is coming from. So there are no rings beyond that one. So, but we'll look into that afterwards. It's a great question. So, and I'm trying to think how far out they are. I think I know. Yeah, like Tethys and Rhea are about the same distance as our moon is from Earth. So it's roughly around 230 some odd thousand miles. But yeah, we'll go back to great question. Thank you. Any other thoughts?
So there's all different kinds of rings. They can be dust, or they can be ice. They can be around very large, massive objects like any of the gas giants, or much smaller dwarf planets, or smaller like Kuiper Belt objects, it appears. But what is it that seems to cause an object to have rings? I notice there aren't any in the inner solar system that we know of.
Yeah.
And yet we have larger and smaller bodies in the inner solar system, with and without moons. We have a lot of the different variants that exist in the outer solar system. We know what it is, and if it is being farther out from the solar system, is there a thought that maybe any object of sufficient size that doesn't have a disruptive moon or other gravitational field does have rings, maybe more or less prominent?
Yeah, it seems like you're right. None of them are on the inside of the solar system. I mean, obviously, maybe proximity to the sun might have something to do with that. That's a really good point. And yeah, they just seem to be more prevalent on the outside. Yeah. You had asked, what was something else you had mentioned before?
Well,
And that's collision. So it's like when, like for example, moons collide, or maybe even if something slams into the, an object. But for example, Neptune's moon Triton is getting closer and closer to Neptune, and sometime, obviously we won't see it because it's millions of years from now, it's going to collide. It's going to be broken apart by Neptune. It's going to be completely obliterated, and Neptune will have a really brilliant ring, unlike the other rings it has around it now. Also, Mars's small moon. Mars has got two small moons. Phobos. Phobos is getting closer and closer. It's like only 60,000 miles or so, right, from the surface. It's very close, and Phobos will also, when it goes probably millions of years, it will also create like a ring, not as dramatic as Triton, of course, but it will still put a ring around Mars. So
So
yeah.
it was a fluke of timing.
Yeah, I guess. But that's a great question you asked. Like,
The inner solar
yeah.
system has been cleaned out by the planets. Their orbits have been relatively, I don't know.
The inner planets are way closer to each other than other planets.
Yeah.
Maybe gravitational effects between.
And I know Jupiter has a huge effect on what comes right into the inner part of the solar system. That's why we're spared a lot of the comets and so forth, because Jupiter kind of cleans them up for us. So
Is the asteroid belt sort of a ring for the sun? Like the sun's a ring within the asteroid belt?
yeah, you can look at it that way. I
If
mean,
you're inside of the asteroid belt, then any of that debris would be pulled into the sun. If you're outside of it, then you would be in the gravitational influence of a further away planet. And so those rings would be, if the particle's large enough, it would crash into the planet. And if it's too small, it would go away from the planet. So it would be a particle of a specific size that would form a ring that would continuously orbit the planet.
yeah, there's probably a lot of tug of war that goes on in the asteroid belt, right? So yeah, it's interesting. It's funny.
Rings on any planets on the inside of the asteroid belt.
Yeah, yeah. Correct. Yeah, and I think too. The asteroid belt. It's sort of when you see a picture of it, it's always an illusion. They're like all these things right next to each other, but it's over pretty much the average is over 1 million miles between each of the objects in the asteroid belt. So, question?
Have they detected any rings from any of the exoplanets?
Just that. I think that right now the stars, the way they just showed you Fomalhaut, and there's planets in there. So maybe as we get more more deeper details and so forth, we'll have more. These are that's very recent. That.
There's never been a direct observation of an exoplanet as of yet. You have to directly observe it to know they had a ring.
Yeah, and thanks for bringing that up. So how do they find these rings around what we looked at? A lot of the times it's what they call occultation. It's when they're observing a planet, right, and all of a sudden it dims a bit in front of a star. The star is, I'm sorry, they're observing a star rather, and this object comes, and all of a sudden it dims, and the star gets brighter again. Then it dims much greater. Then it comes back out. Then it kind of dims a little bit again, and then it's gone. So basically it's passing in front of a star. So because again, you saw in the case of Core, I showed you the image where the successive nights it's moving in front of those stars. So they do that. They look at these objects in front of stars so they can see if they have rings or not. So yeah. Oh, well, we can call them ring particles maybe, but if we keep it up, we'll have a complete ring probably, right? So, any other questions?
Gravitational mechanics. Can you make a strong analogy between an accretion disk around a star and rings around a planet?
I'm not sure. So when you, yeah,
The
yeah.
masses are vastly different between a typical star and a planet. It's
Well, of
less
course, it
than-
would be on a far larger scale.
Yeah, well, don't know.
Yeah,
Need to talk to the astrophysicist about that.
that's why I put historical approach on it. So, yeah, because it's not me, but yeah, it's a really great question though. So, any questions at all? Or I hope you guys found it interesting. Like I said, my goal was to at least show you that there are other worlds out there that have rings around them. It's not just Saturn, you know. So
I mean, I know our moon was bombarded in what they call a late heavy bombardment period, like 4 billion years ago. I mean, all these small moon satellites going around Saturn and others, they're certainly heavily cratered as well.
yeah, yeah. And to give you an idea, it says Saturn is a great spot for this too because there's, for example, there's a moon called Hyperion of Saturn. It's the largest non-spherical body in our solar system. So maybe not counting the dwarf planets. Well, no, they're kind of spherical, just kind of flattened like eggs. But basically, that was a big moon, and it got blasted by something. So there's just a lot of collisions, you know, and what we see of Hyperion today, which is still, I think, close to 300 miles across, or close to it, is just what's left after that collision. You know, it's just shaped, it looks like a sponge or something. It's kind of crazy.
Like that picture you have of Pandora, that's a pretty large crater for that particular moon.
They do. And you're absolutely right. And also, like even Mimas, which is a bigger moon, has an 88-mile crater in it, which is just like crazy. So,
Wow.
yeah, lots of craters.
All right. Appreciate your time and the research you went into. You're right. I have no idea there were that many rings around. Again, you come here, you always learn something, right? That's like I was today years old when I learned all this. So, thanks again. I appreciate it. Next week, our talk is actually going to talk about something here on Earth. It's dinosaurs and the sort of a dinosaur experience. Professor Bruce Oldfield from SUNY Broome will be here. His talk is always very, very popular. He always brings evidence that he's acquired over the years of dinosaurs, and well worth checking out. So, assuming there's not some great or that the CME doesn't completely wipe us out electronically, we'll look forward to seeing you here next week. Thanks again.